Good morning, students. Welcome to video lecture on microwave and optical fiber communication. Subject code U18EC709. Topic numerical aperture. Propagation in optical fiber. Single mode transmit one signal per fiber. The cable has a core diameter of around 9 microns. A multimode fiber is a fiber supports the propagation of multiple modes. The cable has the core diameter of around 50 to 100 micrometers. It causes more distortion and gives less bandwidth than single mode fiber. The total internal reflection at the fiber wall can occur only if two conditions are satisfied. Condition 1. The refractive index of core must be greater than that of cladding. That is N1 greater than N2. Condition 2. The angle of incidence must be greater than the critical angle. Acceptance angle. In an optical fiber, a light ray undergoes its first refraction at the air core interface at this position. From air through source, the signal will be launched into the core area. Here, N0 is the refractive index of air. The external angle of incidence within which the light ray is accepted into the core and is able to travel into the fiber, and this angle is called acceptance angle. And this is the condition where light enters into the core region with total internal reflection. Rays with acceptance angle theta less than or equal to theta max are totally internally reflected at the boundary between the core and cladding. As these rays propagate down the fiber, they remain trapped inside the fiber, that is shown by this path. And the rays with acceptance angle theta greater than or equal to theta max refract at and pass through the interface between the core and cladding. This light may travel in the cladding for a while, but it is eventually lost from the fiber. It is shown by this path. Cone of acceptance. The cone of acceptance is the angle within which the light is accepted into the core and is able to travel along fiber. The launching of light wave becomes easier for large acceptance cone. This is the cone of acceptance. If the angle of acceptance greater than theta max, the light will not be trapped inside the fiber. And here, the angle of maximum acceptance of cone, that is theta naught max, is equal to sine inverse square root of n square core minus n square cladding. That is sine inverse root of n1 square minus n2 square. Numerical aperture. Numerical aperture of an optical fiber is a figure of merit which represents its light gathering capability. Larger the value of numerical aperture, greater the amount of light accepted by the fiber. the value of numerical aperture in terms of N1, N2 and N0. N0 is the refractive index of air. For N0 is equal to 1, N1 can be written as sin theta naught max is equal root of N1 square minus N2 square. Here, the index difference theta and numerical aperture are related to the core and cladding indices are Na is equal to N1 root 2 delta. And here the value of delta is equal to N1 minus N2 by N1. This equation is valid for step index fiber, not for graded index. Numerical aperture depends only on refractive indices of core and cladding material. Na is not the function of fiber dimension. Critical angle and acceptance angle. Refer to the equations. Sample problem on numerical aperture. Problem 1. Calculate the numerical aperture and acceptance angle for a fiber cable of which refractive index of core N1 is equal to 1.5 and refractive index of cladding is N2 is equal to 1.48. The launching takes place from K. Here you are supposed to calculate the numerical aperture. The formula is given. Na is equal to root of N1 square minus N2 square, refractive index of core, refractive index of cladding. Substitute in the given formula to determine the angle of to determine the value of numerical aperture, and from that you can determine the angle of acceptance. Theta naught is equal to 14.12 degrees. In the same way, refer to the model problems on numerical aperture. Problem 2 with solution. Problem 3 with solution. Fourth problem with solution. The last one. Thank you. We will meet with the next lecture.